Today, what you're going to be actually doing is you're going to be building, one of these pencil sketch effects. That effect that's going to take your picture and then it's going to convert it into like a pencil sketch. You understand? So yeah, so we are going to be using OpenCV and then also NumPy to be achieving this goal. Yes, and then it's going to be a really some interesting project, and then hopefully by the time we're done with this too, it's going to enhance you know your skills with uh Python. You understand? And what when you split what is it? It is exactly that we have to do. You understand? Into some key steps. You understand? So what I think is, most any project we import our dependencies. I hope I spelled that right. So now let's try to just go from top and then fill out, you know, our comments. You understand? So to import, yes, I said we need um, OpenCV. Oh my god, Open. Oh my god, OpenCV, and then we also need Pi. Yeah. Okay. Now to make your life easier, common syntax and what almost at least according to what I've seen, almost everybody does is import numpy as np so that when you're using it or you're calling it later in your work, it's not you don't have to type more, just some little, readability and all. Yes, everybody knows that np is numpy. You understand? Yes. Now these are the backbone libraries for computer vision in Python. I'm not going to go a lot into computer vision, you understand? But OpenCV, we can go into, let's just go. Let's go. So now what's our main function going to look like? Okay, so we have to define our function, of course. What should we call it? What should we call it? Let's see. Pencil sketch. Yes, that's very original. Yes. And then now let's see what's our function going to take. Okay, so ideally we are working on, let me see, we need our function to take our images. So let's just say image. How would the function? Okay, now the function is going to get our image by the image path, and then we need to do something uh, with our image. And okay, and that's going to be our what? Our save path. I'm going to leave this empty for now. Yeah, yes. So now we can write, uh, all the rest of this. We can work now in our function. Now, okay, we have done the logic for our function, the arguments that our function is going to be needing, and now we have to load. We load up our images, and then we can do whatever we want to do with the images. So now, for OpenCV is very simple. Now we call our images just image, whatever image we want to load, we are going to store it in our variable, image. So we say cv2 dot imread. Understand? Like you're just reading. How do I put it? Yeah, self-explanatory basically. So yes. Now this is going to load our image for us, and then that's basically that. That's all what you need to load our images. You understand? But let's do some, error. Let's handle some errors in case we have some errors. Like if you didn't do all the setup and your stuff is not in the same directory like me over here. Python is notorious with the backslashes and the blah blah blah. Yes, so I'm going to use a raise keyword. I'm going to say yes, value error. What should I say? What should I say? Okay, so error. The image was not loaded. Check the okay, the file path like this, and we could, you understand? Yeah, so now that's going to handle any you know issues, so that if we do run this, like nothing gets if we do run this and we okay, let me run it, and then we actually don't have nothing in our parts, we have not set up all that, we don't run into in yes, so as you can see, that has run error free because we are still in development, and even after development this is still good to keep, so that we don't. Okay, so now after we've been able to load the images, we are going to want to what? We are going to want to resize them. You understand? Now, okay, let me just go into the code a little later. Yes. So I actually had to do a lot of tinkering to get, the sizes that I want to work with. But I ended up going with 800 p. What the hell is that? Sorry, 800. Just keep it in your head that is px. You understand? And then basically you can adjust based on your needs, like your preference. I hope I spelled that right. Yeah. So now we can keep this as our maximum size. Why? This is the size that we want to cap at. Like this, our highest we are willing to go. Because as you know, these resolutions and stuff keep going up, the more harder it is to work with. These images and stuff in our OpenCV. Understand? Yeah. And now we go and then we name our variables. Height and then our width. And we say call the shape on our image. Understand? The image we loaded, and then okay, say image dot shape, and then I'm going to leave it at that, as I feel like the video itself is. I think it's been 10 minutes. Yeah, I think 10 minutes have passed by. So let's try to make this snappy. So now I'm going to take our height and then the width of our image, and then if that's greater than our threshold that we have set, that's our max size. Yes, now if this is exceeding this threshold of ours, then we are going to need a scale factor. You understand? So we are going to need a scale factor. And again, I'm not really going to go into it, but we need a scale factor. And then yeah, hopefully we all took some math class and we know what a scale factor is. So yeah, we basically get that by our maximum height, so our threshold over the maximum of our image, the maximum dimensions of our image, which we now know to be our height and then our width. You understand? And now we are going to take this our scale factor. So now we are going to reset our image, like update the variable to hold the ideal parameters that we want it to hold. Yes, so we say cv2 dot resize. Yes, this is where the resizing itself comes in place. And we say image. Uh, mm, I don't remember if. Let me see image. Uh, yeah, I think it takes in yes the same width and then the height. in width. Yes, it's going to take in the width, and then our height, and our height is also an integer. Now you can see that I've been casting these as integers in this particular line. That's because now we are going to take our scale factor we got, and then we are going to multiply it by these dimensions, you see here. So once you're able to do that, boom, then we have the ideal image that we want to be working with. You understand? Yes, so that. Yes, that's basically that. Yeah, I think yeah, that's it. And now we can take this image that we have resized, and then we are going to convert it into grayscale. Yeah. So now to convert to grayscale, I think OpenCV gives us, CV to color. Yeah, to color. Yes, OpenCV gives us this wonderful, you know, function method or whatever you want to call it. Here. So image, that's going to take in our image, and then here's the thing. We say CV true, dot, say color in capital letters. That's how the method works. Another one. Yes. And so we are going to take it from RGB to gray. You understand? Yes. Now to my surprise and to very much everyone's surprise, OpenCV doesn't do RGB. It's basically the same thing, red, blue, green, but it's BGR. So BGR to gray. And that's some OpenCV. Let me see package. I don't know about that. Yeah, I really don't know about that. Yeah, so that's pretty much it to get it to what grayscale. Now we're going to do some steps to actually get the sketch effect. You understand? Yeah, we're going to do some couple more steps to actually get our sketch effect. Now, uh, yes, okay. So now we are going to invert our gray grayscale image. So now this particular image that we just converted to grayscale, we want to invert it again, and I'm going to get into the why in a minute. Just write with me, write with me. So we say yes. Invert it. Yes, let's call that. So now you can say inverted is equal to 255 minus our gray image. Yes. Now once again, I'm not going to go into this. Hold on to why. Oh, okay. Yeah, sorry, I just wrote out the without assigning it to anything. Yes. Thank God for these code editors. Back in the day, there was no indication. And, oh my God, the vacuum must have been held back. Yes. So nowadays, our inverted, you're storing this our 255 minus our gray image to be what? Inverted. You understand? Yes. And now we are going to apply something we call the Gaussian. I hope I'm pronouncing it right. Gaussian blur, and also our median blur. Yes, and it's all going to come together in a minute. Like right with me, right with me. So now Gaussian blur. Yes, let's see bled. I'm going to call my variable bled. Yes, I'm being really simple because I don't want to confuse anyone. I'm probably even myself. So we say Gaussian blur yes, that's why we had this our inverted line. So it's also going to take inverted image. Now we are going to go with 21 by 21. And again, ride with me. We are going to get into, you know, the reason for this soon or not. I think this is more mathematical. Let's do. And now we come again. So after doing this, we come and do our median blur again. Now all this is going to be stored into, our blurred variable. So at this point, our blurred variable is going to contain our median blur. So CV, okay, I've already said CV. So CV2 dot media blur. I don't know why it's not popping up for me to just median blur, and then we pass in blurred because we went from an inverted variable to the blurred variable. So now we have to pass in our blurred variable. I don't know if you get what I'm saying. Yes, if you study the flow, but I might be just speaking too much. So yes, blurred, and then we also pass in what 5. And now our image that we have blurred to, we have to come back and then what? Invert it. Yeah, I know this is getting crazy, but bear with me. You invert the blurred image to, yes. So inverted blur. Again, I'm really creative with the variables. Inverted blur is that's it, 255 minus blurred. Yes, like I keep saying, we moved all the way from our inverted variable. Now we are using the blurred variable. We have used it twice actually. If you know, if you get what I'm saying, yeah. And then now we are going to be doing some, you know, division. You understand? So when you are doing division, it's a good rule of thumb. Like we don't want any, undefined. It's going to lead to all sorts of errors if you can actually encounter some zero values. You know, yeah. So let me just get ahead of that. It's no zero division. And again, this is all going to come into light. So inverted blur. So we can simply say our inverted blur equals 0 is equal to 1. So whenever our inverted blur over here, because we are going to be performing divisions, whenever is equal to what 0, we set it to 1. So we don't have any unexpected and unwanted actually headaches. So now we have to normalize our scale, dynamically, if that makes any sense. Yes, dynamically, like so if I say in real time, yes. So this is where our numpy is going to come in. Yes, so we say scale again, very much original. Scale equals mp dot mean as a numpy dot mean. So I'm taking the mean of our gray image variable, and then we just say plus 50, so that I don't know, this is going to create some sort of adaptive. I don't want to say illusion because it will actually be adaptive. So yeah, and then let's create our sketch variable over here. Yes, now to get our sketch, this is where the illusion comes in. So we say CV2 dot divide our gray image, no inverted blur. I think that's what we did. It's not a flow though. Okay, yeah, inverted blur, and then our scale. the scale we just created. Let's just say scale equals scale. I think you're supposed to hard code it, but let's just dynamic. Let's be dynamic. Yes, and I'm going to explain how we did all this blur inversion and blah 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 blah. Yes, now this is a technique to create uh, our pencil sketch. That's yes. So uh, yes, now our inversion blurs. We're supposed to create our pencil sketch. So we simulate how pencil shading is going to work, and then our data areas are going to get more pencil strokes. You understand? And then for the Gaussian blur, I set 21 by 21 because now this is going to give us smoother transitions. You understand? Yes. And then the medium blur, we went with 5 by 5 because now we don't want a lot of noise. You understand? Like we want everything to be clean. Yes. And then our division is key because we are dividing our original image by the blurred image. You understand? By the blurred image, all the Gaussian, everything we've done, like all this flow to manipulate our image, and then we do some division. You understand? And it's going to create the sketch-like appearance. You understand? Yes. So when I say division, like think of yes, all this is happening in terms of let me say computer language, numbers, and yes, that's why I said division. Yes. Hopefully you're able to understand all that. Yes. And then now I think we have got to display our results. We can actually get visual. Uh, yeah, you can actually get visual with stuff. Yeah, so it's a CV2. Wait, what do I want to do? What do I want to do? Yeah, okay, so let's create our our safe path for our sketch. Yes, let's create our safe path for our sketch. You understand? And now, okay, let's also show. Let's switch to the time show. Mm, our sketch image. Let me write the string sketch. I don't know. I'm so used to this being so hard. I'm so used to just writing img, but for the benefit of yeah. So sketch image, and then again, our second argument is going to be uh, our sketch, right? Yeah. And then now we have to do our weight key. I think it's going to be 0. Yeah, switch it out to weight key 0. Yeah, 0, 0. And then we are also going to destroy all our windows. So switch dot destroy all windows. Yeah, like this basically. How should I? This like an escape, like so when you hit close, we know that we are close and everything. Yes, I think that's basically it. Mm, yeah, that's basically it. And then if we run ideally, we shouldn't get any. Yeah, but let me put the parts away. So yes, okay. So let's have a look at my test images. Yeah, okay, so this is my first test image, and then you can see how it currently looks. Yeah, very colorful and beautiful. Yes, es muy bonita. So let's copy the relative path, and then we are going to plug it here, right here. So paste, and then hopefully when we run, we are going to create. No, 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 I made a mistake. This is our save part. So our save part should be sketch image dot yes, sketch image. I don't want to tinker with the extensions just yet. Why did we load our image into image part? So where's our image part variable? Let me go ahead and run the function, and then so we have a better idea of what might have, maybe something's wrong, maybe something's wrong. So yeah, okay. So let me use my test img. Yes. Dot jpg. Yes. So by looking at the function, like what we initially really did is it's going to, when we are calling the function, we need an image path, and then a save, and then the function is going to save the image to this save path over here that we have hard coded as sketch img. Yes, so I'm going to call the function with this my test image, and hopefully we don't get any errors. Okay, that looks good. That looks good. Oh shit. Line 43, line 24. NumPy dot and array is not callable. NumPy dot and array is not callable. And line 43. On God, there's nothing wrong with line 43. So let's see line 24. Yeah, I might probably cut all of this out. I don't want to waste your time. But oh, oh, okay. Yes. So the kernel parameters are supposed to, okay. So Gaussian blur is taking in 3 arguments. That's what I think is going on over here. Yes. I'm calling. We said it's not callable, right? So yes, this was calling this, and I think it's just a variable it is not supposed to. Let's go again. And clear our terminal and boom. Let's do it. No. Line 43. Like on God, there is nothing wrong with line 40. So sketch. Did I spell it right? And like 38. CV2 dot. I am right. Do not find a writer for the specified extension in function CVV. I am right. Cannot find a writer. But I define the safe part. Why? Okay, let me add the extension and see if let me add the extension and see if that works. Okay, almost worked. Yeah, I still have some errors down there, but I still have some errors down there, but it worked. Let's see. It said the wait key and what? Yeah, there's nothing wrong with pencil sketch. But, yeah, so that's how. Yeah, so as you can see, this is our outcome. Then we have been able to blur. Yes, so this is the original image, and then this is the blurred image, as you can see. Yes, now this doesn't sit well with me, so I'm going to keep on trying to find what's going on. Again, I might cut this out. You know, you guys don't want to see all of this. What's going on here? Wait key. I always use my wait. This it. Um, yeah, yeah, yeah. That did it. That did it. Yeah, yes. So now we can have our image, yeah, and then we can expand. We can do whatever we want. Yes, but I think our size restrictions are even still working. All the pre-processing that we did. Yeah. Now let me try on my second image. Yes. What could go wrong? I mean, tech is so fun. Let's see. Let's see. Let's see. Let's see. Let's see. Let's see. That looks good. That looks good. That looks good. Yeah, that's our second image. Well, I actually didn't show the preview, but yes. Okay. So now what's happening is if I go to my sketch image part over here, now it has this course. The part is just updating with whatever image I'm working with. Yes, so this is our real image, and this is what the sketch brought out. Yes. So yeah, it's been a blast.